Hello everyone. So in this video we are going to discuss about Ethernet and ARP. So we are referencing to the James F. Coursey book, which is computer networking, a top-down approach with Cat W. Rose. So before we start with the deep dive understanding of the Ethernet and ARP, first of all, I would like to convey some important information about the general terms about Ethernet and ARP. So it would be very helpful for us. So I search something. So what is Ethernet and ARP? The resolution protocol. It is the full form of ARP. Uses a simple message format containing one address, resolution, request, or response. So ARP contains one address resolution which can be request or response. The packets are carried at the data link layer of the underlying network as a root payload. In case of Ethernet, a 0 cross 0 806 Ether type value is used to identify ARP frames. The definition is given by the Wikipedia, and let us have some diagrammatical view of this. So it would be very helpful for us to understand more. So I hope understand this way. So see, I hope that it is visible, or I might open this one in this way. Sorry. Yes. So routing under normal operation is very simple. We have a lane user and which is connect and the lane gateway which is connected with the hub switch, and the lane gateway is connected to the internet. So lane user is not directly connected to the internet. In between we are having some connection with hub and lane gateway, but in routing subject to ARP cache positioning. So lane is connected to the hub, and it is also connected to the malicious user too, and link gateway and internet. So a successful ARP spoofing attacks allow an attacker to perform a main in the middle attack. So malicious user can have the access to attack to the lane user, which are the local user. So it is about the ARP. So we would not waste out more time in the normal discussion. So uh, So we are told that capturing and analyzing the Ethernet frames. So we are going to do these portions. So I have cleared my browser cache. So my browser cache is already empty. So no need to do this, but you can do this because I have read this PDF, so I have done this before multiple time. So now this time we are going to enter this link. So before entering to the link, we need to just open the WireShark. So my WireShark is on in the backward side. So now I'm going to uh, take that link, and yeah, this is a normal amendment link. Something is written over there, which is a simple HTML file with extension of HTML. So we are done with these steps. Now we are going to stop Varsha. So I want to tell a simple thing that I have captured this packet before the time when I am going to record this. So I tell you that how we are going to do this step easily. So simply when we are going to capture the packets easily just by clicking over this, and the WireShark would be open on the other side. So at that time various kind of packets will be generated over there, as you can see. So you need to do one thing is just that click on analyze, and then click on to the enable protocols, and came to the IP internet protocol, and search for the IPv4. So it would be damn sure like this, but you need to unmark this one and tap OK. Then no need to worry about that. Nothing crime you have performed here. uh, you are not in the custody of police at that time. You are doing some normal operation in your system. So these are the total steps which are told over there. So you at that time we would having the IPv4 protocol informations, and the protocol would be the ARP 0x08086 and Ethernet. So it is as simple as that told here. So these are the all steps which are told over there. So now we are going to perform and learn something over there from the WireShark. So before moving, I would like to tell some important information. So suppose I am having this packet of this protocol, and the information carries is about the IPv4. So see, the source is this, and the address of this is name sensor is this. So globally unique factor default is there. So the bytes that this packet carries is 52 bytes, almost around. So destination of this packet is this, and the source is this. And as you can see, there are the ASCII code are producing, which are there. So section number is one, and interface ID is there of this, and we can also see the arrival time of this packet with the local time too, and the time shift is there. So it is the frame number 5 because I have clicked on the frame number 5. We can also see this here. So the length of the frame is 66, and it is having the 52 bits, not bytes, and the capture length is 66 and 528 bits. So frame is marked false, and frame is ignored false, and the protocol frame is ether type data. Okay, now we are going to move towards the questions which are over there. So what is the 48-bit Ethernet address of your computer? So it is asking the 48-bit Ethernet address of my computer. So it is asking for my computer Ethernet address. So let us see it from there. As you can see easily that it is 00 colon 09 colon 5b and colon 61 colon 680 colon 6d. So let us move to the another question, that what is the 48-bit destination address in the Ethernet frame, and is the Ethernet address from Gaia CS or umass.edu, and what device has it at its Ethernet address? So we can check it easily in this. So my destination address is what sorry uh, so my destination address can be seen easily. It is nothing but 000C 4145 colon 90 colon A8 uh, is not the eternal address of the that JRCS me edu. It is the address of my this links router, season router. So let us move to the next question. That how many bytes from very start of the Ethernet frame does ASCII G in the get appear in the frame? So let us see that how many bytes are produced. So we will see that how many bytes we are getting. So as you can see that we are having somewhere around 42 bytes easily. So now we will move to the next question, which is that what is the hexadecimal values of the CRC field in the Ethernet frame that we are having. Uh, Let us see in the Wireshark. So the hex value which we are having is the 0x0 d 0a 0d 0a, which is very easy to find, nothing hard over there. So the next question is, what is the destination address in the Ethernet frame? So it is very easy to find that we need to get the Ethernet address, and Ethernet address is this for this one 10066F and DN78563. So these are the questions. So before that, and it is now asking for the what is the where is the get address get method is found. So we need to find out the get request first. Uh, we need to find for the get request. Uh, we are looking for the get request, and definitely we will get the get request because it would be there somewhere around get request. Yes, this, yeah, get request. So we have got. Now we should look around that what response it would have to get. So 304 not modified. So the response we have got is 304 not modified. That ranges to byte A and has 58 cent cache control. And so maximum age is 9 and date is written over there and all the time and the details is written. So we would get to the again this one. So we have found the get request. Let us look for this. So the frame 12 is the get request packet, and the section number is 1 for that. Interface ID is 0. So interface name is written over there, and we can see the arrival time shift toward this. Frame number is written over there. Frame length is there. 336, and destination is written with the address, and the source is cloudnet, and address written over there, and the destination is Shenzhen, and the address is also written over there. So it is very easy to find for this. So type is IPv4 because we have searched for the IPv4, and in the hexadecimal we are having this ARP Ethernet. So data over this packet is 322 bytes, and of course the length of this is 322. So it is the get method. Yes, of course. So let us move forward. Mm, yes. Now it is asking for the 10th question, which is uh, which is very easy. And let us see what are the hexadecimal, and and value for of the CRC field in Ethernet frame. So Ethernet frame containing AARP request message. Let us see in this. Sorry, let us close this one. Oh yes, Wi-Fi. So the hexa value is we have found earlier is same 0x0d and a0 0d a0, which is written in front of you as you can see. So let's look up to the another question that so the 14th question is this that what are the hexadecimal values for source and destination addresses in the Ethernet frame containing ARP reply message. So we have seen this one. So the source address was somewhere around 00D051 that we can see over there. Yes, the source address was yes 00 D05989 3D68 something, and the hex value for this is uh, 345 times FF, which is the same. So let's look up for the another question. So it is asking for the Ethernet case one. So we need to open this one file. So we are going to before opening this, we should close this one without saving. So we are going to open the file. Yes, WireShark. It is asking for the Ethernet E file. Yes, here it is asking for the uh, first and second ARP packets in this trace correspond to an ARP sent by the computer running WireShark and ARP sent in the WireShark by the computer with the ARP request. But there is yet another computer network as indicate packet 6 and another ARP. Why there is no ARP reply in the packet trace? So let us see that why there is no ARP reply. So for the 15th question, there is something theoretical answer. So firstly, we need to search for this. That why there is no uh, ARP reply. So we would look for the frame and the internet. Yes, for the first frame, we will look at why there is no reply. Mm, so I haven't seen any reply. So there can be a situation that there is no reply in the trace because we are not at the machine that sent the request. So it could be happen that the ARP request is broadcast, but the ARP reply is sent back directly to the sender, which is the Ethernet address. So it could be happen generally when we are not the sender. Sorry, we are because we are not at the machine which has sent the request. So ARP request is broadcast. Okay. So ARP reply is sent back directly to the sender Ethernet address. So this could be happen. So we are done with all of this question today. So I hope that you have got the all the idea about the Ethernet and ARP. And so thank you.